So today we're going to be talking about finding the inverse equation. So remember that a function is basically any line or graph that only has one y-coordinate for every x-coordinate and is written as fx. Also remember that the inverse of a function is basically the opposite or the reverse and undoes the original function and is written as f minus 1x. Okay, so since the inverse function is the opposite, and we know from previous lessons that the x and y values switch places, we can conclude that in order to find the inverse function algebraically, we can take our original function, switch the x and y, and isolate for y to find the equation of the inverse. So here we have the example of fx is equal to 2x minus 5, and it's also written as y is equal to 2x minus 5. So using our steps, we can switch the x and y around. And so now that we have that, we can isolate for y to find our new equation. So we do that by bringing the 5 over to the other side, and then dividing both sides by 2 to get y by itself. So then we have our new equation of x plus 5 divided by 2 is equal to y. And that would be written as f minus 1x is equal to x plus 5 divided by 2.
In example 2, we are given the equation f at x equals 4x minus 3. And now we have to find the inverse of x. So we'll start off by writing the equation with writing y instead of f at x. So it's y equals 4x minus 3. Now we have to switch the x and y values. So it would be x equals 4y minus 3. And now we have to isolate for the y. So we start by bringing over the 3, making it x plus 3 equals 4y. And then we'll finish it off by writing, bringing the 4 over. So we'll divide both sides by 4. So we get x plus 3 equals 4, or over 4 equals y. And then you finish off the entire thing by writing it as f inverse at x equals x plus 3 over 4. For this next example, we have to find the inverse of the equation when x is equal to 5. So we start by writing out our inverse equation that we found in the last example. So f, the inverse of x, equal to x plus 3 over 4. And then we just substitute the x with a 5. Make sure you put brackets around the substituted number. And then you just do simple arithmetic and you find the answer. So 5 plus 3 equals 8 over 4. And then you reduce it, and that equals to 2. So the inverse when x is equal to 5 is 2. This example is similar to the last one, except we just have to switch the 5 with the negative 3. So the inverse of negative 3, you write out what the inverse equation that we found in the first example, x plus 3 over 4. And then you switch out the x and the negative 3. So x becomes negative 3, put brackets around it, and it's all over 4. Now you just add them together, so negative 3 plus 3 is 0 over 4. 0 divided by 4 is 0. So the answer of the inverse of negative 3 is 0. So for example D, all we have to do is find the equation when f at x is 3. So f at 3, and then we put it into our original equation, 4x minus 3. and then we just swap the 3 with the x. And then you multiply the 4 with the 3, get 12 minus 3, and the answer is 9. So f of 3 equals 9. And then that leads in to example E. With example E, this is a special case. This example, we actually don't need to do any work because we have to find the inverse of the equation at 9. And in example D, we see that f at 3 equals 9. And if you inverse f at 3, you get that. And that's the exact same as the example right there. So what happens is f at 3 equals 9 inversed is also f of 9 equals 3. So then that's the answer for example E, is that the inverse at 9 is 3. Now we're on to example 3. 3a, we have to find f at 4. So this one's pretty easy. All we got to do is put 4 into our original equation, 2x plus 8. So all we have to do is switch x with 4 plus 8, and then 4 plus 8 is 12, 2, multiply it by 2, you get 24. So f at 4 is 24. This next example, it wants us to find the inverse of the equation when x is 6. And since we haven't already found the inverse equation, we want to try and solve this without solving for the inverse equation, just so that we can save a bit of time. So since we haven't found the inverse yet, and we're being asked to find a number within the inverse, we can actually see that f minus 1 when x is 6 is actually equal to y in the original equation. So what we can do is we can switch y in our original equation to x plus 8. We can switch y with 6. So then it becomes 6 to x plus 8. Now, all we have to do is solve for the x. So to solve for x, we have to isolate it. So we do that by dividing both sides by 2.
So then we would have 3 is equal to x plus 8, and then we have to move the 8 over to the other side, so we would have 3 minus 8 is equal to x, and then we would have negative 5 is equal to f at negative 1, 6. So in this question, it's asking us to actually find the inverse equation. So we do that by switching the x and y's in our original equation. So our original equation was y is equal to 2x plus 8. So then we switch the x and y, so we would have x is equal to 2y plus 8. And then to start isolating, we divide both sides by 2. So we would have x divided by 2 is equal to y plus 8. Then we have to move the 8 over to the other side to isolate for y. So we would have x divided by 2 minus 8 is equal to f negative 1x. And that's our inverse equation. So now that we have our inverse equation, we can use it to solve for this question. So our inverse equation was y is equal to x divided by 2 minus 8. And then we can just substitute in our 10. So y is equal to 10 divided by 2 minus 8. Using Ben Miss, we know that we have to do 10 divided by 2 first. So we have 5 minus 8, and so f negative 1 at 10 is equal to negative 3. And also please note that if a question does not ask you to find the inverse equation, then you can find the answer using the method for 3b. But if the question does ask you to find the inverse equation, you have to find it and use it, and that's all.